welcome to class number 15. Our goal for today is to use constant velocity, or excuse me, constant acceleration equations to find the unknown. Use position versus time, velocity versus time, and acceleration versus time graphs to describe the motion of the object. So we're going to check out a couple equations here. So the first question here says, at the bottom of a hill, a car has an initial velocity of 16 meters per second. So let's write that down to start. VI equals 16 meters per second. The car is uniformly accelerated at negative 2.2 meters per second squared. So that tells us that the car is slowing down by 2.2 meters per second each second, all right, for 5 seconds. So t equals 5 seconds as it moves up the hill. So it's going up a hill, it slows down, which we expect. How far does the car travel during this 5-second interval? So d equals our unknown. All right, so what we can use is, let's see, we have time, we need d, we don't have v final, so we should probably use this equation here. D equals v initial times time plus 1/2 at squared. All right, so d is our unknown. V initial, 16 meters per second. T is 5 seconds plus 1/2, negative 2.2 meters per second squared times 5 seconds. That's squared. So these seconds are going to get squared with the 5, so that's going to cancel with that. And seconds cancels with seconds, so d equals 16 times 5 is 80. 1/2 of negative 2.2 is negative 1.1. Negative 1.1 times 25, because that's 5 squared, is going to be negative 27.5. And I think that comes out to be 62, not 62, 52.5 meters. I think that's about right. My math might be a little off there. Might want to double check me on that. Now the next one, we have a watermelon. That is 77.5 kilograms. And it's colliding with the ground. Calculate how far, so we need displacement. It must fall freely from rest. We have two pieces of information there. The initial velocity is 0, because it's from rest. And the acceleration, because it's falling freely, is 9.8 meters per second squared. So that it will be traveling at 29 meters per second the instant it hits the ground. Now, we're kind of talking about like the impact velocity, right? So I know like after it hits the ground, it's 0 meters per second, but like we're talking about like that as it hits the ground, what's its velocity? All right. So we don't have time, so we're going to use the timeless equation. Vf squared equals Vi squared plus 2AD. So Vf squared is going to be 29 meters per second squared plus 0 squared, or excuse me, not plus, but equals 0 meters per second squared plus 2. A is 9.8 meters per second squared times d. All right, so 29 squared I think comes out to be 841. 0 squared is 0. We have 19.6 d. And we're going to divide both sides there by 19.6. So 841 divided by 19.6 is about 43 meters. All right, and there we have it. Excuse me. All right, so now we're doing some position versus time work, and this is really good for the quiz that's coming up. So the first question is, the slope of position versus time represents velocity. Really important point there, velocity. All right, or speed, but we're gonna use velocity for now. All right, because the direction is gonna matter. So from 0 to 3 seconds, what's going on? Well, from 0 to 3 seconds, you see a slope. Okay, so we know the slope represents velocity, so we have a constant slope, so constant velocity, and it's positive. So you can either say moving forward or constant positive velocity v. From 3 to 6, let's see, from 3 to 6, there is no slope, and the position is not changing, so it's stationary. Or it's a 0 slope, not no slope. So 0 slope, 0 velocity, stationary. From 6 seconds to 9 seconds, the slope is constant but negative. So it's actually moving backwards, right? It's going from 30 down to negative 20. So moving backward. Constant negative velocity, right? So what is the average velocity from 0 to 3 seconds? So in order to do that, you're finding the slope. So let's see, rise over run, rise, run. So the run here was about 3 seconds. The rise was about 30 meters. All right, so velocity in this case of a position versus time graph is equal to the slope, is equal to rise over run, which is equal to a rise of 30 meters over a run of 3 seconds, 10 meters per second. Look at that. If you keep track of units, it tells you that the slope is equal to velocity. Where is the object still? I mean that more in the sense of time. So these two should be like at what time? All right, we already said that's from 3 seconds to 6 seconds because the slope is 0. How can you tell? Slope, i.e. velocity, equals 0. Where is the object moving backward? We already said from 6 seconds to 9 seconds. How can you tell? Negative slope, which is velocity, so negative velocity. How quickly is it moving backwards? So find the velocity. So we have to find the slope here. There's a few ways to do this. Some people found the slope going all the way down to here. You can do that, but it's a little hard to tell like where this lines up here with the negative 20. So what I like to do is I like to just use the slope here. The slope is constant. You find it one place, you found it everywhere in this section. So this is 2 seconds about, might be a little less. And the rise here is 30, but it's going down by 30. So it's actually be negative 30 meters. All right. So slope equals velocity, which equals rise over run, which equals negative 30 meters over 2 seconds, negative 15 meters per second. All right, there we have it. At what time does the object return to its starting position? So let's look at where it started. So this is position, so it started at 0. It went away, stayed there a while, came back. It looks like at about 8 seconds it returned to its starting position. So now we're looking at velocity versus time graphs. There's other information we need to know here. The slope of a velocity versus time graph represents acceleration. The area under it represents displacement. My pencil just stopped for a sec. I think we're back though. Yeah, displacement. All right. So again, slope of velocity versus time is acceleration. Slope of displacement or position versus time is velocity. All right, the area under velocity versus time is displacement. So describe the motion of an object using words, or the object using words. So from B to C, what's happening? So B to C, some people say it's stationary. No, it's not. Watch out. What are we measuring here? Velocity. So from B to C, it has a constant velocity of 20 meters per second. From C to D, the velocity is going up. So we call that acceleration. And from E to F, let's see, it's going from a velocity of 40 to a velocity of 20, so it's slowing down. So we'll say this is positive acceleration, we'll say this is negative acceleration. Is the object ever stationary? Well, the object can only be stationary if its velocity is 0. So the only place its velocity is 0 is where it starts. So at the starting position, A. What is the object's maximum velocity? Remember, looking for velocity here. Don't care about the slope right now. Velocity is just given to us by the y values. So it looks like the maximum velocity here is 40. What is the object's displacement over the first 4 seconds? So we need the displacement from here up to this point. We need all this in here. So there's a few ways to do this. We need to find the area. There's 2 ways to do that. You can find the area of this triangle here. Okay, 1/2 base times height and add it to the area of this rectangle. That can work. Or this shape is also a trapezoid, so you can do this equation. Is a little bit more advanced. Area equals 1/2 base 1 plus base 2 times height. So 1/2, let's see, base 1 is going to be at this bottom here, so we'll say 4 seconds, plus base 2 is going to be up here, so that's 2 seconds, times the height, which is 20 meters per second. All right. So 1/2 of, let's see, this is 6, so 3 times 20 is going to be 60 meters. Where is the acceleration 0? Again, I should say at what time. So at what, for all of these, time is the acceleration 0. So let's see, so acceleration is the slope. So where's the slope 0? Let's see, B to C, D to E, F to G. So BC, DEFG. Where is the acceleration and maximum? So again, acceleration is the slope. So where's the maximum slope? Looks like to me the steepest part is going to be C to D. Where's the acceleration negative? So where's the slope negative? E to F. This is a really important point here. Even where the acceleration is negative, the velocity is still positive. Okay, it's still moving forward. So a lot of people think that just because the acceleration is negative is that it's moving backwards. No. If you have a positive velocity and a negative acceleration, you're simply slowing down. Okay? The sign of your velocity tells you if you're going in the positive or negative direction. Now, I didn't clear this out yet, but you know what? I'll just leave it here. I forgot to erase all this, but we'll just leave it. So number 17 says, what is the acceleration of the object? Real simple. It's an acceleration versus time graph. It's constant. It's a nice flat line at 6, so that's our acceleration. Okay, this is not a velocity versus time graph. Some people are like, oh, the slope is 0, so it's 0. No, it's not. It's an acceleration versus time graph, so the acceleration is given to us by the y value. Is the acceleration changing? No. Why not? Well, look at the acceleration. 6, 6, 6, 6. It doesn't change. It's the same the whole time. So this question says, if the object started at rest, what velocity does the object reach after 3 seconds? Okay, so starts at rest, initial velocity 0. Time is 3 seconds, acceleration is 6, v final is unknown. Vf equals vi plus at. The final velocity would be 18 meters per second. There is a more advanced way to do that one. Okay, the more advanced way is to understand that the area underneath acceleration versus time gives us the change in velocity. That's a little bit more advanced, but it's something that might be worth knowing, right? And number 20 says, does this graph give any information about the object's velocity or position? So it gives information about how the velocity is changing. The velocity is changing by 6 meters per second each second. But without the initial velocity, you can't get the final velocity here. If it were 0, then yeah, you could, but unless you're given that, you can't really do much. Same with the position. You don't know anything about the position unless you know the initial velocity. Again, if the initial velocity is 0, then yeah, you can do some work with it. But if it's not, then this graph doesn't really help you. Right, so definitely use this whole worksheet as help for your quiz. Make sure you can do it and you understand what the slopes and areas represent for each type of graph. And if you have any questions, feel free to ask me. All right, have a great day.